All right, so what do we got in front of us here? We've got two graphs of quadratics in standard form. And I say this, and you're not doing it, you need to try on your own and then watch the video. Don't just sit here and copy me. That's not what this is for. I didn't make these videos for you to copy from. I made these videos for you to look and see if you needed help. That's what the videos are for. They're not for copying. Copying does not work. It doesn't. You have to legit be trying. You can tell in class who's trying to do something while I'm doing it and who's not. It's obvious. All right. This one might bug you. I'm not going to do any more, but you need to maybe add a 0. I don't know. Maybe. I don't know. All right, let's see here. You're supposed to create a table containing 3 points, the vertex, the y-intercept if possible, and another point found using the axis symmetry. Your vertex is always going to be at negative b over 2a followed by f of negative b over 2a. I know that notation is kind of confusing, but that's where she's at. All right, so a is 1, b is 2, and c is negative 2. We don't need c today. We need it tomorrow, but we don't need it today. Anyways, getting a good habit of knowing what a, b, and c are. So I'm going to follow my little formula here. H, which is the x-coordinate of the vertex, is going to be at negative 2 over 2 times 1, which is negative 1 when everything's said and done. I'll put that in the center of my table, okay? It also happens to be the axis of symmetry. To find k, I plug a negative 1 in. That'd be a negative 1 squared plus 2 times the negative 1 minus 2. That's 1 minus 2, which is negative 3. Take away 2, which is negative 5. That, by the way, was h and k. All right, so I know the point negative 1, negative 5 exists on the graph. Oddly enough, don't have enough room for it. And I also messed that up. That's negative 3. That's a positive 1 minus 2. Glad I caught that. There she is. There's my vertex. From here, since a is 1, we have this kind of slope being 1. Kind of slope. Rise 1, run 1. There's a little more to this, but for right now, that's enough. So the other point was at negative 2, negative 2, and then we have 0, negative 2. The axis of symmetry helps you do that. If one of these points is here, the other one must be there. Domain for any quadratic is negative infinity to infinity. The range of this one is negative 3 to infinity because it's your y values. Small value is, I said that wrong. The small y value is 3, the high y value is infinity. Apparently I need to take a break. Let's see if I can redeem myself. We'll look at number 4. Now, I didn't actually go through this process on that one, but I'll put it on this one. Notice it says the y-intercept if possible. All right, let's find h. H is opposite b, so negative 4 over 2a, 2 times the negative 1. This is going to end up being 2 when everything is said and done. To find k, I take that 2 and I plug it in. You know, this is supposed to be an easy skill, but it's a skill that a lot of people just get wrong, like probably 1 in 4. That's negative 4, 2 squared is 4, plus 8 minus 3. That should be 1. So 2, 1 exists on the grid, which should be up here. Now, it mentions the y-intercept. By the way, while I'm doing this, my axis of symmetry is x equals 2. Mentions the y-intercept if possible. The y-intercept happens when x is 0. So we're going to find f of 0. It would be a 0, negative 0 squared plus 4 zeros minus a 3, and that's going to spit back negative 3. There's kind of a note, it's in your notes somewhere, but in standard form, the constant is always the y-intercept. Notice it says in standard form. So 0, negative 3 exists. Now I'm going to use the axis of symmetry to find the other point. This is 2 units left. There must be another point 2 units right, and it's at 4, negative 3. I'm not surprised by the shape of my parabola. The reason I'm not surprised by the shape of my parabola is simple. There's up and down. Notice I tried to keep... I have none absent. Thank you. Thank you. Notice I tried to keep the initial slope to fall 1 run 1 because there's a negative 1 there. Domain is going to be negative infinity to infinity. You'd have to be a mouth breather not to get that by now. The range, the low value is negative infinity for y. We rise all the way to 1 with a bracket. I'm going to pause for a second and try and clear my brain. I've got a bad case of fog going on right now. So just give me a few minutes, I'll be right back. All right, let's see if I do any better now. Determine what transformations have occurred to the mother function f of x is x squared, which, by the way, because a large number of you have not memorized her yet, she has the 3 key points 0, 0, 1, 1, and negative 1, 1. She looks like that. That's what she looks like, plain and simple. Have occurred for each given equation by converting to vertex form. So we're supposed to convert to vertex form. Now there's a little bit I can tell you right now. This tells me 2 things. There is a reflection over the x-axis, also known as a vertical reflection, and we have a vertical stretch with A being 2. So it's twice as tall for the given amount of x territory covered. All right, I can tell you that just by looking at it. That's it. I can't tell you the translations. I can't tell you if it's going right or left or up or down. That's what vertex is for. So we're just going to do the straight up conversion. We're going to find h. We're going to do opposite b over 2a again. So opposite of b, and by the way, a is negative 2. For those of you who don't know your alphabet, b is negative 36 and c is 8. Opposite of a negative 36 is a positive 36. 2a, twice a negative 2. That's going to be 36 over negative 4. I learned my multiplication tables in 4th grade. Surely you can figure these things out. If you can't, like if you're going to be that dunce, be glad I don't design calculators, because if I did, it would probably give you a cussing. You'll probably type this in, and it's wrong because you forgot to use a master set of parentheses. Or maybe you're not aware of this, but you can go to math, you can go to num, you can hit the up arrow, and you can just pull up fractions. Who knows if I've shown your group that or not? I don't know. Ta-da! Negative 9. Anyways, now I want k. I find k by plugging this in. Forgive me, I'm tired. Negative 2 times a negative 9 squared minus 36 times a negative 9 plus 8. Now those numbers are a bit big, and nobody's asking you to do that by hand. I'll show you 2 ways of doing this. The first one is just by typing in what's said. Which is pretty easy to do. It's 170. It's big. See, I wouldn't have guessed that it was shifted up 170 units. The other way is the storage feature. I'm going to take a negative 9. I'm going to hit that STO button. I'm going to store it to X. And then I'm going to type in the equation. Storage feature is absolutely wonderful. It's like the best thing since sliced bread. 170 either way. You may not see the value in that, but some kids do, and they're the ones who tend to do better. Anyways, I got 170. This is my A value. Remember your form? It's got an A. So f of x is -2, x minus a -9, because it's minus in the form, quantity squared, plus k, so plus 170. And you know as well as I do that taking away a negative is addition. A negative minus take away a negative is a positive. There you go. Now you can see other shifts. This is a left 9, and this is an up 170. So I've got my other two transformations. I was translated left 9, and I was translated up 170. And I'm using some different vocabulary here because you're supposed to know translation, shifting, things like that. All right. Put a little trig in here. I'm not supposed to teach you trig this year. It's not in your standards, but you need to know trig because it's on the ACT. So there's always going to be a little trig. Every once in a while, I got to throw some trig. Number 8 is the same as 7, so I'm just going to use these details. I am told the tangent of angle A is √5/2. It's a right triangle ABC. So I'm just going to draw a right triangle ABC. I like to put A in the lower left-hand corner and go clockwise. That's me, but what do I know? I know that from SOHCAHTOA that the tangent ratio must be the opposite side over the adjacent side. And I also have this perfectly good ratio, √5/2. Just make the horizontal connection here. Opposite of angle A must be a √5, and adjacent angle A must be a 2. Now, I'm also aware of this really old theorem called Pythagorean theorem. It says that a squared plus b squared is c squared. So here's a, here's b. 2 squared plus √5 squared is c squared. Now, if you're one of those kids who has just been socially promoted your entire life, you have no idea what a √5 squared is. It's 5. You're going to have to do stuff like this. Oh, it's 5. Who would have thought? You guys are going to start paying attention in school. Anyways, 4 plus 5 squared is c squared. So that makes a 9 is c squared. I would not have guessed this, but anyways, c is 3 because we take the square root of both sides. There you go. I should have guessed that. It's an old example. Why did I do that? Because you're supposed to find the sine of angle A, right? So the sine ratio is opposite over hypotenuse. You're at A. The opposite length is √5, and the hypotenuse is 3. There you go. Let's see here. I think there's 2 of these old Soviet Russia problems. Yeah. I'm fascinated by the Ukraine war, by the way, so I'm going to do 11. 10 works the same way. In the modern Soviet Russia, aka the Russian Federation, failing students are sent to the front lines in Ukraine to drain the West of bullets, because that's what's happening. However, since we are modeling quadratics, we will stick with the catapult examples. The Soviets were just cruel to their people. I say launched out of catapults, but if they didn't like you, they sent you to a work prison. That's what they did with you. Or they killed you. They killed more people than Hitler. The Soviets were bad. Committed genocide regularly. The path of a failing student would be parabolic in nature, and the height of a student at time t could be modeled by the quadratic equation in the form -16t squared plus a sub t plus h of 0, where a is the initial acceleration and h subscript 0 is the initial height. So suppose a catapult launches a student from a height of 12 foot. This is h0. with initial acceleration of 256. This is A. Write an equation modeling the death of this poor failing soul. So height as a function of time is negative 16t squared plus A is 256t plus 12. There's your equation. Find the maximum height. The maximum height happens at the vertex. So here it's t. T is opposite b, negative 256, over twice a negative 16. And that's going to be what? Negative 256 over negative 32. Signs cancel. Seems like that's 8. So it happens at 8 seconds. It doesn't mean the maximum height's 8 feet. The max height happens when you plug an 8 in. It's h of 8, which means let every t be an 8. So negative 16 times an 8 squared plus 256 times an 8 plus 12. Negative 16 times an 8 to the second plus 256 times an 8 plus 12. 1,036 foot. That's on up there. While I'm doing this, I'll show you something. I'm going to take my equation, I'm going to put it into y1. I'm going to use x's instead of t's. All right, so I went to y equals, I typed my equation in, zoom 6. We hadn't done much playing around on the calculator in a while. We're about to. I'm going to look up. I'm going to look way up. I'm going to change my y max to be 1,200 foot. Y is going to be height, okay? Hit the graph key. And there is the path of the student. They go up and they come down. I'm going to hit second trace 4 for maximum. And I'm going to take my cursor. And I'm paying attention to what the calculator says. The calculator says left boundary. That means get left of the maximum, press enter. Now it says right boundary. Get right of the maximum, press enter. And then enter for a guess. 1,036 feet happened at 8 seconds. There's rounding errors, by the way. So that's kind of cool. Term when the individual goes splat. I just did a video a few minutes ago. From your perspective, you might have watched it yesterday. The individual goes splat when the height is 0, because that's when you hit the ground. So we're going to take our little equation. We're going to set it equal to 0. And now we're going to do something called the quadratic formula. And again, it goes x equals negative b plus or minus square root b squared minus 4ac all over 2a. We're just going to plug into that thing and be done with it. This likely doesn't factor. A is a negative 16, B is a 256, and C is a 12. And I'll check this with the calculator too, by the way. It's really easy to do. And I'll probably use a calculator as I do my calculations, to be honest with you, because the numbers are going to be hideous. Apparently, I don't have any ink pens. All right, where was I? All right, so opposite B. X is a negative 256 plus or minus square root of a 256 squared. I don't have a clue what that is. I'm sure somebody in this world does, but I'm not that person. Times A, which is negative 16, times C, which is 12. All sitting pretty over twice A, twice a negative 16. Now, I know a lot of kids, they like to just be done, one and done. There's a reason I don't one and done these things in the calculator. That is the decimal. That is the square root of all that stuff. All right. So x is negative 256 plus or minus 257.4956. And it's sitting over a negative 32. So I'm going to do the two operations. I'm going to add, sorry, one of them is negative 256 plus that dude. I'm going to press enter, divide it by negative 32, and I get that x, in this case it's actually t. One of my times is about negative 0.04, let's say 7 seconds, which is obviously nonsense, right? It's an extraneous solution. The other time, which is probably going to be the correct time, I'll call it time 2, is going to be the negative 256 minus, and notice I'm just arrowing up here to get that decimal. Press enter, divided by negative 32, 16.05 seconds. There's my time. Think about being airborne for 16 seconds and then hitting the ground. You're going to be terrified. All right, what else we got here? $12 and $13 are identical. The dual enrollment teacher loves these problems. If for those of you taking dual enrollment next year, she'll do one of these on her test. She always has. Person is wishing to fence in their backyard because their dog keeps biting the mailman. They are flat broke, but happen to know an individual 300 foot of fencing available free. They intend to use their house as one side of the fence. What is the maximum area they may enclose? So you have a house, and you're going to build a fence in your backyard. You can use the house as the fourth side. So it's a rectangle. And the area of a rectangle has always been length times width. Got to know that, all right? You have 300 foot of fencing available for free. The traditional way of doing this is to call the widths x. We let the width be x. Well, what does this mean? That means if you have 300 foot of fencing available, then the length has to be 300. Take away whatever these x values are. Take away both of them. And now we're going to plug into the area of a rectangle formula. She is length of 300 minus 2x times the width of x. Oh, and I need to go back here and look at this one in just a second. I forgot to do that. I'll do that in just a minute. Now, putting this in standard form by distributing, we get negative 2x squared plus 300x. I probably should have mentioned talking about domain and range here, but I forgot to, and I'm not going to fix it. The state likes to ask weird questions. There's the area of my rectangle. Your max or your min, they always happen at opposite b over 2a. They always happen right there, always. So a is negative 2, and b is 300. So this is going to be negative 300 over twice the negative 2, because it was opposite b. That's 300 over 4, negatives cancel, it's 75. So the x value here was 75. I'm just going to kind of draw my little three-sided rectangle here. This is 75, that's 75, which means this is 150 because we had to add to 300. Now, I want to know what the maximum area they had to enclose was. I can do this one of two ways. I can put that x value there, or I can just look at my pretty little picture. Doesn't matter. But area is length times width, so it's 75 times 150. Of 11,250 square foot. Sounds like a lot, doesn't it? 1 acre is 43,560 square foot. This is about a quarter of an acre. It's not a whole lot of ground. Don't think it is. Now, I said I was going to go back and show you this in a calculator. I've already got this guy from doing work earlier in Y1. So I'm going to put this guy in Y2. All right. I'm going to hit the graph key. Notice it drew y equals 0 down there, that horizontal line. And I'm going to look right for an intersection. I'm just going to set my X max to 25 just to look right. And I can see those two are crossing points now. I'm going to hit second trace 5 for intersect. That's something we've done. I'm going to take my cursor, I'm going to get it close, and I'm going to press enter 3 times. 1, 2, 3. Same time. All right. What do we got here? Convert something into standard form. We did some of this yesterday. It's not hard. We're going to write the x plus 3 squared twice. Then we're going to invoke that double distributive property. X times x is x squared. X times 3 is plus 3x. 3 times x is plus 3x. And 3 times 3 is plus 9. And then we have this minus 8. Notice the parentheses, form and structure is where it's at. Now, I don't want to write a whole new line here, but 3 plus 3 is 6. And if you multiply that by a negative 2, you get negative 6x in the middle. Now that I've distributed the negative 2, I don't need the parentheses anymore. Being lazy here, I'm forgetting to write down g of x. And I can actually combine my like terms. Negative 18, take away 8, should be negative 26. And that's what she looks like in standard form. All right. Last thing I'm probably going to do is a domestic terrorist problem. A domestic terrorist rolls a tree that is 55 feet in height, standing 12 feet from the center of the tree, and throwing from an initial height of 2 feet, the roll clears the tree by 1 foot and lands on the other side. All right. So you're the domestic terrorist. This is you on Halloween night. You're throwing a roll of toilet paper over a tree. You are 12 feet. Now we're going to put your roll of toilet paper right here at the origin, 0, 0, 0, 0. And the roll of toilet paper is 2 feet high, so it's at 0, 2. That's where the toilet paper is. The tree is 55 feet tall. You clear it by a foot. So the height here, the y value is 56. You are 12 feet from the center. That would make this 12, 0. The coordinates for the center of the tree where the toilet paper clears it are 1256. And eventually you're going to want to know the x value here. The y value is 0. All right, write the equation in vertex form modeling this rat. We're going to use y equals a times x minus h, quantity squared, plus k. And I actually have run out of time. So I'm going to come back to this. Bell's about to ring.